So the craftsmanship here, if they pay attention, can do very, very good results. Okay. So, but you can see the most of the concrete are gone, and then all the rebars are exposed. So this may be a case where they don't have enough cover. Okay, rather than actual rebar erosion problem. Okay. And more cases, and in this case, chunks of concrete, and we don't know if this chunks of concrete is actually coming from here or from above. Okay, so the beams and the remaining, and even the bottom of the tank have all chunks of concrete start falling. So you have to do a forensic to really elaborate, where that concrete is coming from, and that is a very important part of the investigation. Okay, this is the stairway that goes up to repair the, or do service to the tank. Now, this compared to the beam and columns, this is definitely rebar, exposed rebar and problems. Okay, so the stairway was not done as well as the structure itself. Okay, so I don't know the sequence of construction here. This may be done afterwards. Okay, and because of the geometric complexity, this may be something more difficult to construct. Okay, and that is why the quality of this is not as good as the actual structure. Okay, and and look at this. This compared to what we've seen before, this is bad concrete, and the steel was not proper either. Okay, and so after they did the investigation, they started the repair work, and even this picture shows very good workmanship. They know that when you repair concrete, you should chip away all the old concrete, and then maybe enhance the reinforcement so that make sure all the corroded parts are being removed. Okay, and then they open up. So the recommendation that Dr. Shen gave them is actually reinforce the columns by enlarge the columns, okay, and the footing. So by excavating below ground, they have been able to repair most of the footing part. Now, there is a danger of what they're doing. Notice that there is no secondary beam supporting the structure, and then they start digging out the foundations. This is very dangerous. Okay, if they start repairing all of them simultaneously, you're exposing people to danger. So, from a construction safety perspective, this is something that
they should give some prop to the columns.
Yeah, exactly. Some kind of prop and support. Yeah, and it's not like they don't have that here, because we have seen some pictures. I think some of the projects that CN has done, they actually have temporary supporting. In fact, one of the failure that we investigated together was actually the support collapse. The scaffold collapsed. So, you have to do everything right. Okay, but in this case, this is definitely very dangerous to do. Okay, and then once they excavate, you can see all these are done by hand. Okay. Once they excavate, they start laying out the reinforcements, okay, and then cast concrete. So all these are done really nicely, okay. And this is actually, you can see the footing concrete is already been laid, okay. So I'm not certain, okay, yeah, so the reinforcements already in place, and so this is a good time to see if they have a good tie together. Okay, and in this particular case, I don't. Oh yeah, there is. So this one is bent L shape, so that is done right. Okay, so those are details that you cannot see until after the construction is over. After they construct, you cannot see those kind of details. So, as the engineer records, this is extremely important to document take this kind of pictures. Okay. Okay, so another thing is, in my opinion, considering the heavy load on top, this rebar is probably a little too skinny. Huh? You should use a larger bar. Do you agree? Larger rebar. These rebars are too thin, in my opinion. Okay,
minimum is 12 mm, bro, sir, for
minimum 12 mm. But this one doesn't look like. Is this 12 mm?
It's 12 mm.
It's 12 mm. Okay.
In intermediate, I think it is 10.
10.
That is small. That they have. They
Oh. You mean the
the
stirrups
yes.
are 10? Okay.
No, stirrups will be 8 or 6.
8 or 6.
That
Okay.
is very small.
Yeah.
I'm telling in the middle. Middle,
This and
middle
this.
one is little bit thinner.
Uh-huh.
So he must have given 10 mm.
Okay.
That he can give.
Okay.
The minimum
Reduce
thing
the.
should be 412.
Yeah. Okay.
Minimum should be 12. The 12 mm, 10 mm is just for some support.
Okay. And then brickwork is starting, okay, for the remaining. Okay, and you can see concreting.
Inside.
Yeah, inside. Yeah. So I don't know whether it's intentional, but you see the rough surface of the concrete. You know, that would provide bonding for the later concrete. Yeah, it's intentional. Okay, now brickwork go all the way to the top of the column. Yeah. Second stage. More concreting. After the second stage, okay, finally they go all the. They start preparing the beams. Additional reinforcement. So this is a very, very interesting part. I don't think in the U.S. We have ever tried this, at least not to my knowledge, by adding reinforcement and additional concreting, because this actually makes the beam bigger, right? Added more dead load to the structure. But luckily, these beams are just really just connection, just support for stiffening of the column. So I think it's okay. And you can see the formwork that was being placed. City engineering inspection. All these pictures one day will be so valuable because this is what people were doing, concreting, okay? And when I was in Chennai, I've seen some large instruments for concreting. And so one day, you may not be able to find those ladies that do concreting. Yeah. When I went to China in 2008, I was showing some pictures of, at that time, Chennai Trichu Road was not completed. And we were driving, and we've seen people laying concrete, putting concrete on their heads and then dumping. And I was like, wow, you see, in India, the highways were built in such a difficult condition. And the Chinese like, that's how we do our highways here too, so I was embarrassed. Sometimes you get this lapse of your mind, but all this will go away very, very soon. When you guys start, maybe 10 years after their service, everything will be automated. Then you will not be able to find all this. Yeah, so these pictures are very, very important one day. Yeah. When I was younger, growing up in Singapore, we have ladies that do that, and that was before Singapore was anything. It was just a fisherman village, okay, and then many years later, I read somebody wrote a book about those ladies, because in Singapore they would wear a red color cloth on their head, and it was talking about the lives of those ladies. So we can see the footprints of people who lead to development and who lead to advancement of a society. But all this will be historical. And then concreting on top, on the beams. And this is after work. Okay, so you quickly realize and you appreciate very much CN's forethoughts and also the design of all of this beam column connections and so forth. Okay, and it served the purpose. Okay, and it definitely has reinforced all the bottom of the water tank, so they don't have to rebuild the entire water tank. Okay, so that's a really amazing project. Now we're talking about rebuild the spiral staircase. Okay, so they were literally rebuilding the entire footing, including the columns. Yeah, and you can see the so even this kind of steel work is really amazing. Okay, because it takes good skills to have the welder on site doing a bent beam and then make sure they are the right dimensions. So this kind of skills will be eventually gone. Okay, in the U.S. we don't have people do on-site weldings anymore. Okay, but this kind of work. No, actually, take that back. The other day when we were helping Ahmad casting concrete, wasn't they doing some steel cutting? Yeah, so in America now most of this work is done by Mexicans, and they would still do this for work. So the lab next to my lab, they are doing some ground. They dig out the foundation for building a strong footing, because somebody is putting a centrifuge for geocentrifuge testing, and so they have to do all this work by hand, and so yeah, most Americans will not do it. They have to hire the Mexicans. Okay, and then start constructing the staircase. Okay, you can see the columns being formed, and then they start erecting the spiral staircase. And then the completion. So you can see the amazing craftsman work that has been put into the construction of this spiral staircase. Okay, and then they cement and paint the surface to make it look nice. And this is the result. So this is really, really special and unique repair project. What is this thing?
Water level.
Water level? Oh, okay. Yeah, the beautiful staircase that was. That was not very far away, right? Along the.
It's near Shancourt only.
Shancourt. Okay.
Just from Shancourt, it is just some
5 to 10 minutes.
Just 5 minutes.
Okay. Mm-hmm. So probably the water is coming from Calvary River, or yes.
It will be pumped.
Pumped. Okay. Mm-hmm. Yeah. Okay. The next one, this is a really, I think this is done by Ramesh and Shen, because I mean, we don't have all the pictures, but from the pictures I've seen, both of them were shown in the picture. But this is one of the. Is this Tanjore Highway?
No, Professor.
No.
It is in the Chennai.
Chennai.
Chennai
Highway.
There is one place called Tuludu.
Uh-huh.
That underpass got collapsed.
Yeah.
This because of the poor farm work.
Right. Poor construction and poor concreting. Yeah.
Mainly the farm work was failed.
Failed. Okay, so it was during construction. Yeah. And so and one of the things that I was trying to understand, so this must be concrete, right? All this debris. I mean, the rebars, massive amount of rebars, but this must be concrete. Poorly formed concrete, right? They are not enough. Seems like they don't have enough water, right? Is that what this is? Because they don't fill it with soil, do they? Like in the construction of.
For this underpass, it should be concrete only.
Concrete only. Okay. Yeah, you see the failure of. So some of these are. Oh wait. So these are wood, right? Formwork, like bamboo. Rebars.
The rebars have fallen.
Yeah, but so much rebars.
What I have heard from Sas thing is, he used to say that the site which is being constructed was not given enough curing period, so the strength was not developed. Then they started casting the deck slab also without proper
Right.
to that site.
Yeah.
So what happens? This side wall gets collapsed. So the entire thing was.
Okay, and so the concrete wasn't even hardened.
The concreting is poor.
Poor, yeah.
The rebars are deck slab, Professor.
Horizontal. Oh, okay.
That has collapsed. Actually.
The entire. Oh, okay.
Now
The
our
entire.
vehicle is going up.
Yeah. Okay. That explains why you have so many rebars, because the number of rebars just amazingly, yeah.
You can see the thing.
Yeah. Okay, so okay. Now it makes a lot of sense. So these are really rebars that going this way, but the whole thing collapsed. Yeah. Anybody die? No. Don't know. Okay. Yeah. Yeah. Yeah.
This time I didn't join, Professor. I was in IIT Roorkee.
You were not here yet.
Stage. I was doing my PhD there.
Yeah, see the rebars extruding from the site, So the bridge deck is the car is traveling this direction. Yeah. So this gray wall is the sound barrier. Yeah. But even the construction process makes me wonder. So the deck, where's the supporting beam? There's no.
It's like a box.
Oh.
The underpass, Professor, like how our NIT Trichy, when we enter, we have an underpass.
Yeah.
It is the same like that.
Okay. So it was box covered, cast in place. Okay.
Yes.
Yeah.
That is
I see.
I think it's also a connection issue, Professor.
Mm.
You can see the joints, everything, the vertical wall was not constructed properly.
Right.
Left-hand side wall.
Yeah. That
is the
that's one of the things
That's
why the bars are all tangling.
Yes.
Yeah.
happened at the time of construction only.
Mm-hmm. Yeah. So how many days are you required since the wall has been built? The box part of the wall is built, right? Or are they gonna put more walls? Because the one that entered campus is very narrow, but this one looks pretty wide. So they will build
that
more.
That one is not planned properly.
Ah.
Planning.
Mm-hmm.
Lots of accidents.
Right. Yeah.
We have to be very cautious
When you
when we turn.
go in
There is
and
no
out. Yeah.
proper turning
Mm-hmm.
radius.
Right.
It's very narrow.
Yeah. Mm-hmm.
We don't know what's coming on the other side.
Right.
So they just kept a mirror.
Mm.
But the mirror is also not
Not.
proper.
Uh-huh.
It's in the
Yes.
not proper alignment.
Right. Yeah. Mm-hmm.
But every day when I pass that,
You go through. Yeah.
Arms and then we will be
No. Yep. Okay. So I'm trying to find out more. Maybe you guys can help me refresh my memory. So this is another case study that CN was showing.
This is in Pudukkottai, Professor.
Pudukkottai.
Actually, this is around 150 years old monumental arch, Professor.
Right.
During Queen Victoria period, that was in 1858.
Yep.
In India, when the Britishers ruled.
Yep.
So they made a monumental arch. So this is full of brick masonry only.
Yeah.
Arch brick masonry. So because of due to the aging of the structure, it is bound to demolish.
Yeah.
So finally they demolished this.
Yes, but so
It was totally unsafe.
it's a symmetric structure, right?
Yes.
And why this side start cracking and not this side? See the
It's the same one what we saw for that Napier Bridge
Uh-huh.
yesterday.
Yep.
We saw the big piers which was cracked. No,
Right.
Professor. In the exact,
Yeah,
in
crack
the exact
open.
fashion,
Right.
Because the brick. This is.
but is this because of cars hitting? I mean,
heard
it's
one
only one
lorry-
side, not both
I
sides.
heard one.
Huh? Lorry
Yes,
turn.
one lorry
Okay.
has hit this.
Okay. Okay.
That time
Yeah.
it got
Uh-huh.
tilted.
Okay, okay. But this is definitely a structural failure. Okay. So you can see on one end you have this big shear crack along the
So he
the
came
break
and hit
wall.
and it got propagated.
Mm-hmm. So they demolished the whole structure.
We cannot repair, no, Professor. It's very difficult.
Yeah.
We cannot repair this.
Uh-huh.
Bricks is very difficult.
Yeah, but can they not use like steel, just tied it together?
But you will lose the elevation, no, Professor.
Ah.
Yeah, you won't get the elevation, right?
Uh-huh. Yeah.
And that too, the crack is very vulnerable.
Uh-huh. Right, yeah.
So they demolished it.
Mm-hmm. Yeah, that's why I was trying to Google.
The lorry fellow has hit.
Hit this,
That's what I came to know.
What happened to the lorry
And,
fellow?
I remember long back he was saying
Yeah.
that a lorry, a truck driver, he came and hit in the night.
Mm-hmm. And then damaged.
And
Yeah.
then damaged the pier.
But that either the guy is drunk, but this one was not. From this picture, usually I thought this kind of structure would be built on an elevated platform. You know, so when he drive his lorry, he would have feel bumpy before he hits the structure, right? He must be really drunk or really sleepy.
Normally, drive is very common here.
Uh-huh.
It's very, very common.
Yeah. Mm-hmm.
2 o'clock midnight means either he must be sleepless,
Uh-huh.
he should be drunk.
Mm-hmm. Yeah. Yeah, so the failure mode is compression shear failure after the truck hits, right? So the gravity load force the foundation, which is already
It's a
open.
good question.
Yeah.
Shift to a dead load as a result of vehicle impact or earthquake?
Yeah. If you don't know what happened, it really looks strange, because a structure as big as that, you will not naturally, after standing for so many years, it will not naturally suddenly bust open, right? Yeah, unless you have a foundation settlement or some kind of event that happened. Yeah. Okay, this is a tank failure. Okay, so I think this is near a temple. Nero, this district. Okay, and so I think the water starts seeping out, right? And then at the bottom you see these big cracks underneath. Okay, and then you can see all kinds of spider web kind of distribution. Now this one is kind of interesting. So you have 1, 2, 3 kind of parallel cracks. I think this is probably some kind of a differential settlement underneath.
Due to uplift pressure of the water, it's an underground tank
Ah.
where the design is not done for your uplift pressure of the water.
Oh, so it's like a punching shear. It push upward. Okay, yeah. But it's an old tank. It's a pretty old tank, right?
No, just he was telling some 10 years old.
10 years old. Okay. Uh-huh. Okay. Yeah. So you can see the crack pattern kind of like radiating out. Is this reinforced?
Because when we are doing the construction, they found a hard rock straight at the bottom.
Ah.
So they have not provided what they anticipated is there will not be any uplift pressure.
Okay.
But as days go on, they got the uplift pressure where it's not being designed for it. There's no reinforcement provided in the top layer.
Okay, so when you look at this kind of cases, you have to wonder, what was the issues. Okay, this is the water pipe, and so I went through my pictures, and remember yesterday I was so shocked to see the power transmission line going into the river. Well, my picture doesn't show those transmission. Yeah. So this is the same picture that, and this was taken, I think, 2014. Yours is later, right? So see how much water we have at this time, and yours is almost dry. Your picture. Huh? This year? Okay. Yeah. So we really have a big water issue here in Trichy, right? Yeah. Yeah, see, this was, they still have a lot of water, so they are still taking water at this site. But the problem here, for those who have not seen this picture, is this pier settled, okay? And as a result, you can see the two beams kind of settled along with the support, okay? So there's not adequate support on at this point, okay? And you can imagine, obviously, then the pipe on top, the water pipe starts to buckle. Okay, so this is the sump, the suction for the water intake design. Okay, so you have those horizontal tubes that goes out. I think there's membranes for filtration. So you're filtering out the river sand, so the purified water can go up, and then the pump would take it. Here's the pump. The pump will take the water and then go through the steel pipe to take it to Trichy. Okay, so this is when the incident happened, and look at how much water it was. Okay, wow. So we really lose a lot of water.
From the PWD, he said that it is impossible
to repair.
Professor Shen was saying, just give me 30 meter span steel
Mhm.
section.
Yeah.
I will rectify this problem
Uh-huh.
between 36 to 48 hours.
Yeah.
So correctly by 48 hours they recovered
They
and Trichy
has water
proper
again.
water
Yeah.
supply.
Okay. Yeah.
We
So
got appreciation from the mayor also.
for
So
for
the
this
minister
project.
also he was directly associated with
Uh-huh.
this and they appreciated him.
Yeah. So this is when the incident happened, and look at how much water it has at that point. Okay. And here is the broken pipe. The pipe was buckled at this point. Okay. So like Dr. Kartik was saying, so CN suggests, so they were saying you cannot go down and then
It's not
pick up the pier, okay, and rebuild the whole thing. It would take longer, too much time. So what he suggested was carry this long beam in, and then put it underneath the pipes. So it spans over the existing span, and supports on both ends, and then put the pipe over. So that is a really, really quick and innovative solution. Okay. Yeah. So you can see people bringing they even brought this crane in. Yeah.
because to lift and to install that girder we require this.
Yeah.
Because manually it is impossible.
Right.
We can't lift.
Yeah. But then my question is, how is the beam shift to this page? This thing cannot be walking in the river, right? So did people carry it?
You can see there in
Uh-huh.
the down portion they have added some sand.
Oh.
They have added some sand and they made some passage.
Okay, so you think this thing drive all the
I
way?
think the water is not too deeper, Professor. Yeah, you can see
From here,
from
the
here,
brown
you
color.
can see the level difference.
Yeah.
They have just filled it.
Oh,
Not that much deeper.
right. Okay. So the thing drive all the way
Crane
to
must have,
yeah. Okay.
They could have gotten it.
Yeah.
There is a passage. This is in the extreme edge. No?
Right.
When we cross that Kodamurti bridge, there is a passage towards the left.
Uh-huh.
I think the pock line should be travelled
From that
way
left.
And,
Okay. Yeah.
if it is inverse, if it is in middle portion, means it is
Yeah.
quite difficult. We have to use some other type of mechanism.
Right.
We have to bring some railing system or
Uh-huh.
something, and
Yeah.
we have to
make-
we have to go with some temporary structure,
Right.
and we have
Uh-huh.
to do it. But
Yep.
luckily this happened close to the support.
So this is a picture I took in 2014. Okay.
And then this is girders were
Yep.
installed, and still it is standing, no problem.
Right.
That has settled, has remained as settled.
Yep.
only.
Yep.
So they didn't touch after that.
Right. Yeah. So I think now is a good time for the city to properly restore this part. There's no reason for leaving it as it is, right?
Anytime it can.
Yeah. Something worse could happen. So they really should go in there and repair, for long term.
But now it's a very good time.
Yes, yeah, no water.
No water.
Yeah, they should do it, yeah. And they can take the river sand for concrete mixing.
Naturally they will do that.
Yes. Yeah, at that time there's still a little bit of water, but now there's no water. Yeah, so, yeah. And I think this is sometimes, I work with CN and you can see his thinking and his working. So this is a really good picture of him. And so we were up there and we looked down, and they didn't do anything at all to fix the problem, But those are new. So those are additional, but they didn't clean it up, So I don't know whether this concrete was from before or after. But they did. CN told me that those are new. You can see it's a new steel. So the city did go in there and do some repair to the water pipe. I think added support.
I think the settlement is around 5 meters or something.
Right.
Professor.
Yeah. Yeah. So they added this to yeah, but they didn't fix the pier. They didn't pick it up. Yeah.
Still it is like that.
Yeah. Even till today. So the loss is because the filtration was bad. So the pump sucks in sand along with the water. And so somebody should have observed a problem before it was, it must suck up so much sand that the pier literally sink. But nobody pay attention, Oh, okay. No, but from the water quality that coming into the pipe, somebody should have seen that water is coming out of their water supply. So they probably doesn't sample the water intake from the big water pipe. So that can be a big issue. Okay. This one I added to CN's original notes because this one is really, really interesting. So I think it's the Care College, right? Yeah. Don't remember the name. So something wrong with the basketball arena, and when they do a coring, they take the concrete out, and then suddenly you get this water coming out, spilling. So Neville, can you show the movie? And the water literally spits out. Very clean water, okay.
They can take bath.
Yeah, take bath. Yeah, literally, yeah, they are so happy. Yeah, see.
He's washing his legs.
Yeah. So underneath the area there was must be a later formed aquifer. A lot of water was saturated underneath, and that water was pressurized, and that's why this happened. Okay.
But see how the pressure concentration
Yeah.
of the flow,
Mm.
due to that flow, how is
Uh-huh.
the pressure?
Yeah. I don't remember. Do you guys remember what Steven was saying? How did they find out there is a problem?
This basketball court is being constructed some 1 or 2 meters below the existing ground level.
Uh-huh.
Nearby pond was there.
Oh, I see.
Construction, there was no water in the pond.
Uh-huh.
As during the rainy season, what happened? The pond got filled up. Simultaneously, the water table here also got filled up.
Did they see the slab lift
Yeah, that was like
bulging? Ah. So imagine how much pressure it literally bulged the basketball arena foundation. Okay, so this is a very fascinating thing, right? Well, even more interesting is CN's solution to the problem. Okay, so before I spill the beans, how would you fix this problem? That CN and I are trying to submit a paper at that time and included this case study, but our paper got rejected. And I don't feel it's fair. So I'm still modifying the paper to include more information. But coming to India many times, I really felt, people are very creative. And there is a Hindi word called jugaad. At Harvard University, they teach a business school, teach a course called jugaad. Okay, so this is not a word that I made up. Okay, but engineering area, we don't realize that there is such a thing called jugaad. And jugaad is called the word. It means an improvised, innovative solution. Okay, and there are certain requirements to qualify a certain invention as jugaad. Okay, so it's not if your solution is based on the design code and everything, it will not be jugaad. Okay, it has to be so creative it goes beyond. And some of the case studies, famous case studies on jugaad solution. One is the $1 fridge that was developed by some gentleman from northern India. So he used clay. I think it was after an earthquake, and his village was, having a very bad situation, and people cannot sustain because food gets spoiled. So he started thinking, what can I do to help my people? Okay, and so he invented this low-cost fridge. Doesn't require electricity, an ice box, literally, and then you can put food in there. Okay, so that guy had no education, zero education. Okay, the whole thing was made of clay. Okay, and I think one of the famous president from Tamil Nadu, what is his name? The guy with silver hair. Yeah. So he gave him an award for his invention, and that guy eventually started a company. In fact, I visited his website. It was really fascinating. So he made this fridge totally out of nothing. Okay, when you have to spend a lot of money to buy an electrified fridge, right? That use Freon. Freon is bad for the air because it takes out it creates carbon monoxide. So Freon kills the ozone. Okay, so our fridge is really bad for the environment. Okay, but he invented this totally non-electrified fridge that can preserve food for a long, long time. Okay, so that is the kind of innovation I see in many of CN's design and repair projects. Okay, so the solution that comes out of CN was actually, and we don't have picture. He doesn't have picture. So what he did is he let the water come out. Okay, and then he put a lot of gravels, rocks on top, and weights the floor back down. Weight, the dead load, push the floor down, and then he put another floor on top of that. Okay, and so as a result, you see that this panel was the same elevation as this. No, not this. Yeah, this too, same elevation. This is the after. This was the before. So you can see that the floor was significantly elevated. Okay, and so they have concrete lay over all the rocks that he put to weight the floor down. Okay, and then on top of that, he added drainage on the side. So now, whenever it rains, this will take the water out of the slabs. Okay, and I believe he put little openings underneath so that if there's accumulation of water from below, it will drain out as well. Okay.
It will drain back to the same lake.
Same lake? Okay, yeah. I don't even have picture of the lake. Yeah.
Actually, he has connected he found where is the root cause, and he used some PVC pipes.
Okay.
He linked all the PVC pipes, and the water was
back to the lake.
Still, the water will be flowing. He cannot do anything.
Right.
And then it was drained out back to the point.
Yeah.
So whenever the rain comes, it recirculates, but it will not come on the
right.
floor.
Yeah.
It will go inside.
Yeah.
So
See, if this is the case study in the U.S., remember the grouting curtain? We would have grout and cut off the.
Whatever we would have done grout or something because of that water pressure.
It was continue, but if you cut off the water connection between the pond and
if the rainfall is heavy after 2 years or 3 years, naturally when the groundwater
the water will recharge
still the intensity, the pressure intensity will be high.
Will be there, yeah. But
in one lecture he showed the pipes. I conducted one course in 2016 or something. So that time he gave a special lecture.
Okay.
So that time I saw he has connected, he found the loophole where it is, and then he made this sort of drain pipes.
Okay, so drains the water back.
Water, everything was
going back to the.
going back
I
to the
see.
Yeah. And he said that water was left to that same pond itself back. So it is just like recirculation.
Yeah. See, if I were to do this project, I'll probably demolish the existing slab, repave the bottom of the arena, and then recast the concrete.
It's the ministers, again the ministers college.
College, yeah.
The one who was directly involved in that settlement.
Oh, okay, okay.
The minister,
But this is a private college.
Yeah, it's a private college.
So he sponsored this college, the same minister.
Yes.
Mm.
His son-in-law.
Son-in-law. Okay, okay, yeah. One of your professors, professor there.
Yeah, professor's wife.
So,
Bhaskar's wife.
Bhaskar's wife. Okay.
She's the HOD.
HOD now. Okay. I think Madhavi was teaching there too,
She
right?
was there for a while.
For a short while. Yeah. 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 This is.
But this is a very large stadium, no, Professor. If we demolish and everything, again it is a waste of money.
Yep. Take out a lot of money to repair this. Yeah. But that's what we would have done. And yeah, our solutions are usually very costly, and not necessarily solve all the problems. Yeah. But CN use this very innovative methods and fix the problem. Okay. And yeah, like you were saying, this is a huge arena. Very, very big span, yeah. Who designed this? Was CN designed the... No,
No, Professor.
he was not, yeah.
He was.
But I'm also very impressed by the large span, okay? So, CN? I see, okay. Okay, so the cause of failures is due to the buoyancy of the rapid charging of water underneath the foundation, pumping.
He was designing that arena. He would be aware about this problem, right?
Yes, sir. It's something like grouting. Grout type. Upon the பக்கத்து the pond would effectively consider pond.
Whatever it is, he will be seeing all the look and corners. He will be asking all the.
That is right. Because of that only the slab has not cracked.
Yeah.
Provided reinforcement, but he didn't anticipate that much of.
Oh, you are sure that he only has designed?
Yeah.
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 Or he just did the third party inspection like that. So few verification. But once he was telling me that he is not directly associated with that, he was saying. Like how airports and other things he was saying like that, he just checked the drawings like that. I'm not sure.
Yeah. Okay, so that is the last slide. So this tomorrow I will present some of my own case studies, and you notice that there is a striking difference between my practice and CN's practice. I only do investigation. I don't provide solutions. Okay, and CN often provide a solution to the problem. Okay, these are just a few of hundreds of cases that he has done. He had so many cases, and actually one of the cases I really wanted to show everybody was, I think it's on the way to, where did we go to? We stopped in a small town. I think we're coming back from what is that place called? The southern tip? Kanyakumari. Yeah, on the way coming back, we stopped at a very small town, and there was a hotel, not hotel, but a shop, and they were building another building next to it. So it was attached building, and he was showing me how the two buildings were attached. It was a 6-story building, and then CN was involved in extending the building to include another section. And I thought that was just fascinating because they were taking out the wall, exterior wall, and then build out, and that was one of the projects that impressed me a lot. Okay, but many times when you work with CN, you realize that he really did a lot of work for many people in Tamil Nadu. Yeah, and that's why we go places, where we stay, where we eat. He knows exactly where we should stop. Yeah, because it's all his friends. Yeah. Any questions about this? I hope this is an inspiration for many of you, because two reasons. One is when you start doing your career as a civil engineer, you will be doing a lot of projects, okay? But document your projects, okay? And this is one thing I think my friendship with Chen, if anything that he takes away is that documentation is extremely important. And hopefully one day he will take all his career's outcomes and publish some books, okay? I started the class telling you about the friendship between R.N. Reika and Ken Copper, okay? And it's the same thing, okay? Reika is an excellent engineer who documents many of his case studies, okay? And that's why he can synthesize and write one of the first books on forensic investigation in India, okay? That was published in 1985, okay? And so I encourage all of you, start to collect your own book, you know, document every case study you have done, good or bad, okay? And then that hopefully will one day benefit other engineers, okay? And that process in our language is called case study collection, okay? So that's a very, very important piece of your career, okay? Yeah, today is a short lecture because I'm not familiar with most of his, you know, there are many things lost in translation, but yeah, this is very impressive career work. Okay. So anything you guys want to share regarding what you learned from CN? Yeah, we have many CN past students and current students. Yeah. But for NITT, this is really, because of CN, you have a really rich history, and many younger faculties are you know, he engaged you guys in the work, you know. So like myself, you know, when I first working with CN, he took me to places, and I've seen so many of his projects. And that's really eye-opening, yeah, and helps us too in our career development. And so this heritage, I would call it heritage, at NITT is very unique. You don't see it in other places. Okay, so I think that's something that hopefully one day people will recognize. Yeah, but you should carry the torch now and do more of this. Yeah, and so I'm very glad those two younger junior faculty came. You know, hopefully you guys start doing. I think CN has a center for consultation, right, at NITT.
No, we department we have engineering consultancies.
Right.
But it's all,
it was not a center.
We are all the factor.
Yeah.
We are all the faculties who take up the work.
Yeah.
It will be coming like a circulation.
Mm-hmm.
So based on their expertise, they will be circulating things, and most of these case studies and everything will be referred to us.
Mm-hmm. Okay. Yeah.
I'm closely associated with him for the past 2.5 years.
Right. Yeah. So you've seen some new cases. Yeah. Mm-hmm.
We have gone for some
bridge load testing and
testing
yeah. I didn't elaborate a lot on the bridge load testing, but I think 2014 CN starts to do a lot of those bridge load tests, which is extremely important. Okay. At the onset of class, I explained to you guys that we don't measure stress. We don't measure load. So the only way to prove a bridge was designed right and has accurate life is to put weight on top. Okay. And so you quickly realize that this is a very unique practice. In the past, I believe, before CN started doing bridge load tests, all the load tests has to be done by SCRC. Yeah, but you know, this is something that I think is a good thing to start. Yeah, but then you really need to have your own set of equipment. Yeah, not just the dial gauge, but also a set of procedure. So I think there should be a book out about how do you do a static load test on a bridge. Okay, yeah. I just want to elaborate a little bit on the bridge load test. So the purpose of a static load test on the bridge is actually find out the deformation of a structure is according to your design. Okay, so you don't put a whole bunch of trucks onto the bridge, but you based on your design, like inference line. Okay, so all of you know how to do inference line, right? So you wanted to find where's the maximum deflection point, maximum moment point, maximum shear. Okay, and based on your design, you take the truck loads placed at those locations. Okay, so that is extremely important. Okay, and once you do the load test and then you calculate the deflection and that confirms with your dial gauge measurements, then that bridge is proven. Okay, and that's the only way to prove your bridge. We have I've done hundreds of bridge monitoring, and a lot of times you use different NDT techniques, but people don't trust your data. They want to do a load test to prove that yes, this bridge is safe for crossing, especially for existing structures. Okay, so you would never know when you start practice that you will be required to do one of those tests. Yeah, and that will be very important. And also, we also do static load tests on roofs. I mean, not roofs, on building slabs. Okay, and a lot of times, building slabs is a little bit different from bridge, because bridge are long, and then you using inference line, usually you'll be able to find because of traffic, right? But for roofs, usually we design for static distributed load. So how do you do a roof slab test? We use water to test it. So you use a very big plastic, like a balloon, and then you inject a lot of water, okay, until it reaches the static load capacity that you designed for. And then if the roof doesn't collapse, you did it right. So that is how we do a static load test. So now, for you, then the question is, how do you measure deflection of a roof? How do you measure the deflection when you do static load test? You have to take all of this out, and then you scaffold, and then you put the dial gauge underneath. Yeah. Otherwise, you can also put strain gauge on the roof. Yeah, glue the strain gauge, and then you put the plastic balloon on top, and then you inject water until you reach the static load test, load capacity. Okay, so those are standard tests in America. Okay, but we didn't start doing static bridge load tests until maybe 15 years ago. Before, it was not required. Okay, and then people have a lot of questions. And now when we do a bridge load test, sometimes we have trucks that actually has an arm that goes underneath the bridge. Okay, and then so you can use your measurement devices from underneath, so you don't have to have the scaffold. Okay, and also the truck, they have scales built onto the trucks. Okay, and then another thing that we've been doing a lot is called weight in motion. I don't know if you do that here in India. So for highways, okay, to ensure that the bridge or the pavement are done right, we use a dynamic measurement method. So the trucks, you don't have to stop the truck just drive by. And then the accelerometers can back calculate how much the static load of the truck, and also what type of truck. And then they calculate automatically if that bridge or the route is reaching its capacity. Yeah. And so all of these are new techniques that are being developed for. But again, civil engineering, your design depends, lives depend on your design, okay? And so we develop all this amazing new technology. Yeah. Okay, so that's all we have for today. Any other questions? Today, your requirement is to complete your homework and submit. You can either submit electronically or printed. How many of you have printed homework you want to submit, or how many of you are going to submit electronically? You mail? Okay, all to nominate? Okay, good, yeah. Yeah. And tomorrow, class starts at 10:30.
10, we will start by 10:15.
10:15?
10:15 means you can finish by 12:15.
Yes, yeah. Uh-huh.
12:15 and then half an hour we can write an exam.
Okay.
Then we will complete the final awards,
Okay.
certificate distribution.
All
and then
at
we
the
will
same
go for-
time?
Yes, Professor.
Yeah, okay.
Before 1:15 we will leave because certificate distribution is
Takes
just 10
time.
minutes.
Yep.
Just 10
Mhm.
minutes.
10 minutes.
10
Okay.
minutes.
Okay.
We just
Yeah.
need to distribute the
Yeah.
certificates
Okay.
who are here.
Uh-huh.
And then we will give you a memento.
Oh, thank you.
Institute memento.
Institute. Yeah. Uh-huh. I think I may have a number of the, but yeah, I appreciate every time. Yeah.
No, I think this memento you would not be having.
I have not
I think.
seen. Okay.
You would not be having. I think
Yeah.
it's it might be whatever you would have some fiber plastics.
Mm.
That kind
Yeah.
you would be having.
Uh-huh.
This is like a tangy or it's a sort of a metal.
Oh, okay.
A copper.
Yeah.
Embedded with some copper.
Okay. Okay. Yeah.
So
Well, not Tangier,
It's a
no
Tangier
Rockford,
base.
no Rockford.
I don't think it's in the NIT logo. I think you will have the
Yeah.
Rockford.
Uh-huh.
That logo will be printed neatly.
I see.
So on
Okay.
that you can see the Rockford.
Yeah. Okay. Mhm.
Maybe we will have a close observation tomorrow.
Yeah, okay.
We have got that
Uh-huh.
memento, institute memento.
Okay. Yeah. Yeah. Any
They
questions?
want,
Yeah.
I think now it's too early. The
Yeah.
guest house also lunch will not be available
Yeah.
now. If you have any doubts and anything,
How about we have a group picture?
yeah.
Yeah. So tomorrow will be more hectic. How about we have group picture today? Yeah.